So, welcome everyone to Wolfson College here in the University of Oxford. My name's David Wallom. I'm an Associate Professor here in the Oxford E-Research Centre, one of the partners within the Institute for Environmental Analytics. So the IEA is a HEFCE funded activity where collaboration between academia, industry and the public sector looking at maximising value from environmental data. And that's environmental data of all sorts, space-based, ground-based, and also people-based. So from that point of view, an important part is not only what we do with it, but how we do with it. And from our point of view, one of the key parts, one of the key technologies and tools is, of course, going to be cloud computing. So our training event today is talking about how we're going to be using cloud computing for environmental analytics. So the agenda for today, so I'm going to give a brief introduction to cloud computing. I realise for many of you it will be a bit of motherhood and apple pie, talking about some of the bits at the more academic level, at more the fundamental model level. But then we've got three presentations from cloud providers. We have Amazon Web Services, we have Jasmine Sems from STFC, and we have Microsoft Azure. And all of these will be talking not only about the capabilities within the services, but also talking a bit about some examples of how they've supported environmental applications from all of the different areas that very broad statement means as much as possible. And then finally, we're going to have from the Met Office, Jacob Tomlinson from their informatics lab, talking about how they've actually utilised cloud computing as services within the Met Office. And then finally, a little bit of discussion and networking. And the aim there really is to allow you both to question those that have presented during the day in maybe slightly more detail, but also then meet between yourselves. Because the other part of the IEA's key delivery is networking between people, not just projects and people within the network, but also outward. So I'm going to start off now with our introduction to cloud computing. And I do have to thank two people, so Paul Watson at Newcastle, but also the National Institute for Standards and Technology, who've done an awful lot of work around how you say what is cloud computing, so how you define it. And as part of that, they've come up with this idea of this working definition of cloud computing. And really, the key part here is to pull out a couple of three words from this more than anything. You know, convenience, on-demand, configurable, but also minimal effort or service provider interaction. It's not about ringing someone up and saying, can I have some computing power, please? It's going somewhere, using a technical interface and getting it really when you want. And that's really a key differentiator as we move above and beyond virtualization services and things that you'll almost certainly have seen within IT services organisations or IT support services within your organisations. So the first thing to think about is very much the top level. What's the different models of how you can use cloud computing? The first one of these, the service models, is software as a service. Many of you, of course, will already be using this on an almost daily basis. I know I do. Sort of here we talk about some of the more social applications, so Facebook, Flickr, but also at the supporting activities in work around Office 365, a lot of Google Documents, things like this. So applications really that are web-based that you just use as and when you want, but platforms that you have little control over. The next one, of course, is Platform as a Service, and that's much more about supporting development, supporting application development and service creation. One of the very popular ones that's gaining traction in this area, of course, is Docker, and Docker hosting, Docker service-based. And from that point of view, it provides a consistent environment from which you can control, deploy, and manage applications across a whole range of platforms. It separates you essentially from the underlying services. And then finally, we of course have infrastructure as a service. And for many people, this is what they think about when they see cloud computing or when they think about cloud computing. It's about the fact that they basically get a remote resource that's controlled completely and utterly by themselves, but on hardware that's owned by somebody else and managed for them. Of course, we're going to hear later from two of the largest infrastructure as a service providers, but I thought also I'd talk about the fact that infrastructure as a service can also be set up at a more private level and can be supported, as we are moving to do here within the University of Oxford, through services through platforms like OpenStack. And this is going to almost certainly form the basis of the new European Open Science Cloud when that service actually comes online. So when we talk about the service models, what are the important things to consider? And this is the key one, it's responsibility. Which are the parts of the activities or operations are you responsible for, and which are those that are responsible or is a vendor or somebody that's providing a service responsible for? And you can see on the left, in-house IT, as you'd sort of hope, you're responsible for everything. And that's the applications all the way through to the fundamental networking at the bottom layer. And as we move through infrastructure, platform, and then software, you can see that the responsibility shifts from yourselves. And that's something that you have to think about. Not only is the fact that the responsibility shifts, but also the interaction and the type of interaction that you're having to support will change. From the point of view of deployment, so how do these clouds actually get deployed? How are they made available? So I mentioned earlier about public cloud. I mentioned our big colleagues, and I mentioned community cloud. So I talked about the Jasmine SEM service from STFC, which is a community cloud specifically for the environmental sciences. We also then have private clouds here in the university and in many other academic and public sector organisations that are completely and utterly set up just for their own services. The important part there, and a particular type of functionality, of course, that a private cloud allows you to do, is service development. You can develop a service within a cloud within your organisation and then look at migrating it to some larger provider as and when you require it. Because one of the key things, and actual private software packages in the past have been developed because of this problem, is service development costs an awful lot if you're doing it within a public cloud. It's one of those things of, you make a lot of mistakes when you're doing the DevOps style service creation. You want to be able to stand services up, you want to test them, you want to tear them down, put them back. You want to be as agile as possible. So having an environment that you can create and run yourself that's compatible with the public cloud that you eventually intend to deploy on is very important. So when people are talking about doing cloud, there's been an awful lot of times when you start hearing somebody say, "Oh, I'm doing all my stuff in the cloud now," and you start questioning more, and you say, "Well, when you say you're working in the cloud, what do you mean?" And they say, "Well, I've got this machine, and I put it up, and I connect to it from my desktop, and that's in the cloud." But there are a couple of characteristics that really make you think, particularly as you're thinking about longer-term support for an activity, longer-term support for some sort of platform service or capability. It is about on-demand self-service, i.e., you're the person that's using it, you go and get it when you want it. It is about high-performance network access, and for those that are here from the academic sector, that doesn't necessarily mean it's going to be as good as the Janet network that you get within your academic organisation. It's about broadband quality access. We're not talking dial-up here. It's about location independence. When you're using Facebook, do you really care where some of your social data is? Hands up who knows where the nearest Facebook data centre is to here. Go on then, Kenji, tell us where. It's in Dublin. It is indeed. It's amazing. There's an awful lot of things actually in Ireland. So alongside the Microsoft data centre and alongside an Amazon data centre actually. So from that point of view, you don't care. It doesn't have to be right next to you. Now, there are, of course, a couple of instances where you might say, well, that's certainly not optimal. For example, if you were doing a hybrid a physical test with computational simulation, for example, of some sort of ship or civil engineering activity, you might not want that because of latency. But if you're operating a wholly virtual environment, you don't care where the physical services are located. What you care about is access quality. The other bit, of course, is scalability. So when you launch your Encyclopedia of Life, for example, if you're the Woods Hole Oceanographic Institute, and you scale your services, and then you have a news item on CNN and BBC World Service, and 2 million people turn up at the Encyclopedia of Life, you really hope that you've designed the service such that it can scale out to take that into account. Because otherwise, your Encyclopedia of Life suddenly becomes the Encyclopedia of not living, of not running, and of not providing service. So designing for scalability is important. And then finally, something that is more important in the public cloud, maybe, than in the community or private cloud, is measured service or accounting for usage. I.e. that there is a thought in your mind when you're using these services that you want to make sure that you know how much is being used and it's being appropriately apportioned. That might be some form of credit-based system, nothing to do with funding, just a fair share. But it may also be real money if you're talking about the public cloud. So just to reflect, the NIST cloud model, something that is now being utilised by governments and by many people to define how they interact with the cloud ecosystem. So how do you use software as a service? Well, as I said, it's about, you're talking about internet-based software delivery. You're talking about software where the internals are not visible to the consumer. You're talking about something that is basically as a front end, also that is delivered uniformly to whoever is accessing it. Now, that may there may be some skinning allowed, so, Gmail, for example. You can get Gmail on a commercial level, and the most customization you can do is to put your business logo on it. All the rest of it stays pretty much the same. So from that point of view, they're about large-scale delivery of uniform software to a whole number of different user communities. So, what's the software that's best provided as a service? Well, the first one, of course, is enterprise applications. Email, desktop applications, personal productivity, business support, all of those sort of things that actually make little or no difference to the actual quality of your business output, as long as they pass a minimum benchmark of quality. No company ever made an improved profit because their email service was better than someone else. As long as their email service passed the minimum benchmark of quality, their business specific value add was what made them money. The other part of this is what I've termed as packaged simple input applications. One that essentially is able to be passed some form of simple configuration and then run in the background for some sort of computation. There's a really interesting one here where we think about how many people use high-performance computing installations now. There's an enormous amount of community applications and software that are effectively black boxes to the community. They pass them a configuration file, and they run, and as far as they're concerned, they've configured they get an output. And from that point of view, that's a perfect software as a service application. It's one that also means that the software vendor can manage, upgrade, and doesn't need to start dealing with the support of, I tried to upgrade to version 4, it didn't work, and now nothing works. The vendor, the software owner, is the person that's in control. But when you're building a software as a service application, what do you need to think about? Well, the first one, of course, is that you need to think about these things right from the very beginning. You can't suddenly decide halfway through designing an application of, I know, I'm going to make this a software as a service app. It's not going to work. But you need to be thinking about three real key things. It needs to be scalable. You need to be designing your software so that when 100,000 people come along and use it, it's not going to suddenly find a single point of failure because everyone's trying to access the same database that, for example, is input conditions for a model. It's got to be multi-tenant efficient, i.e. you need to make sure that you get good sandboxing between consumers, between users of any particular piece of software. In some ways it needs to be configurable, but configurable by you. It needs to be able to be managed such that when you are doing upgrades, when you are changing the software delivery, that your consumers are not going to see that change until you want them to. Who's logged onto eBay and suddenly noticed that it looks a bit different from the last time that you went on? Have you ever seen that? So eBay can replace their entire platform across every single one of their data centers without altering eBay time, which is the key thing, without losing track of any transactions in 2 minutes. So that's something they've designed into their application as a key requirement from the very beginning of saying, because we're essentially selling trust. They're almost like a bank. They're selling the trust that a buyer can go through and formulate a transaction with a seller. From that point of view, they need at the same time to be able to upgrade and manage their platform. They can't just stand still. It wouldn't work for them. The next one, of course, platform as a service. So here, this is around the user being the software developer. These are different platforms, different software development environments across many different languages, across many different providers. And they're essentially application hosting environments for people to deploy their applications into. And when you look at what's included by the service provider, you can see the list is very, very long of all of the bits they take care of for you so that you don't have to think about it. All you have to think about is the API that you're programming or deploying your software or services against. So what are the benefits to platform as a service application developers? Well, the first one, obviously, is you don't need to buy any hardware. It also means that the non-expert developer doesn't need to worry about setting up the development environment in the first place. They're managed and available for people to actually work against. We, of course, have flexibility and adaptability. From that point of view, it's just a software development environment. How you interact with it is key. But the other part that you will have seen for many people is this really facilitates the idea that people don't need to be geographically co-located, that development communities, development teams can be disparate but still work coherently together. And we see this quite a lot with contract software development springing up from different places around the world. And that's particularly beneficial for the small and medium enterprise that are talking about, well, how do I get a particular piece of knowledge that I need at a cost-efficient methodology? So then finally, infrastructure as a service. Well, let's think, what is traditional IT purchasing? So, I want to buy a server. Well, the first one is I get a grant. I tell my IT guy when I get the grant that I need to get a server of a specific size. I've got the grant now, so I've raised the funding and I go and purchase it. If it's a really big server, if it's a cluster, I then have to go through European procurement rules, which means, of course, that my cluster doesn't arrive maybe in the same year that I've got the money. And then finally, I consume it. From that point of view, there are a few issues. Funding. I need to buy a set of physical hardware at a particularly, at possibly a large cost. Obviously, you can't buy half a computer. You can only buy whole computers. So from that point of view, if your application or service is not going to fit a whole computer, you can only go in unit scale. And then the really big problem, of course, is the utilization. So anyone in HPC that tells you their utilization is more than 65%, quiz them a lot harder. because it's highly unlikely. Now that means there's 35% of a very large, very expensive HPC service, which basically equates as sort of the bottom 10 of this left-hand rack, have been bought, are consuming electricity and really are not actually doing anything useful. So from that point of view, that's a bit of an issue. And a graphical way of thinking about this is, there's hardware, there's the operating system, there's your applications, and there's waste. And there's wasted capacity, but there's also the possibility of business failure or application failure. So if we think of Animoto, so when Animoto launched, there was the amount of service they required bobbling along the bottom. Then all of a sudden, they got a bit of publicity. Hate to remember that. And all of a sudden, their utilisation absolutely skyrocketed within months. So they couldn't have bought physical hardware that would have actually supported that increase in utilisation fast enough. So what would have happened to their business? It would have failed. Because in this sort of environment, if you go along and if Flickr's not there or Flickr is not doing as you expect, it's just poorly performing, you're going to go somewhere else. So from that point of view, they look at everything, people would go, well, we're just going to go off somewhere else. So what do you do within the infrastructure as a service cloud, of course, is you have your hardware, you have what's known as a hypervisor, which manages virtual systems, and then you virtualize everything above that, your operating system and your application. And then you can then over-provision. Because of this fact that everyone doesn't use all of the capacity they want all of the time, you can effectively squeeze more into a particular piece of hardware. And then when you start aggregating these together, start putting them together as a service, you end up with football pitch-sized data centers. And from that point of view, you end up with data centers, and I think, Kenji, this might be one of yours, actually. Possibly. So from that point of view, there's a scale-up that's enabled here, the scale-up that you just cannot do personally. So, thinking about all of the different service types, all of the different deployment models, what's new about cloud generally? Well, the big one is this on-demand thing. It's about the fact that there is this illusion of infinite capacity, this illusion that there is always resource available for you, and it works. You don't need to make any upfront commitments. You don't need to make hardware purchasing decisions. You need to decide, I want to use my credit card, and I do, to actually buy some resource, or I need to go and talk to my community cloud provider and say, can I have some resource? The other one, of course, if I decide, because cloud is not a panacea, cloud is not going to hold different applications that maybe are not in the right environment. So if you decide after a while that actually, this cloud looks good, but it's not really what I want to do, you haven't made an investment of £100,000 that you then need to justify, well, I don't need it after 3 months because I've made the wrong decision. So that's a very important thing. So it's about agility, it's about transferring this idea of capital expenditure into operational expenditure, it's about scalability. There are, of course, downsides. Everything has a downside, unfortunately. The first one is failure debugging. So when you're developing your services and when things do go wrong, you have to remember that responsibility chart. You need to remember that, there may be times when there are failures that you can't really track down that may be complex. And this is why when I was talking earlier about having a system or having a mechanism by which you could develop your services in a more close-to-home environment may be convenient. The other one, unfortunately at the moment, and the European Open Science Cloud may solve some of these issues, is around vendor lock-in. And as they're both here, I can say this. If you develop your services in Amazon, it is exceedingly difficult to then migrate to Microsoft. If you develop your services in Microsoft, it will be very difficult to migrate to Amazon, because there is not a widely adopted by the public cloud sector open standard for interfaces into cloud computing. That is in development, and that's one of the things that Europe is pushing. From the point of view of, of management sort of responsibility, as I mentioned before, if you're using infrastructure as a service, you do have to not just be a software application developer. You do have to be a systems administrator, because you're responsible, remember, for all of that bit from the hardware up. So you're responsible for keeping the operating system of your service hosting machine secure. You are the person that if you suddenly become part of a spam bot, the National Cybercrime Unit may come along and say, what's going on here? This is your machine. So you need to think about that. So when you're choosing your cloud infrastructure for building an application, there are certain things you should think about. The first one is this idea of centralization or federation. Can you actually spread your service across providers? Can you make it so that you're not locked into any one provider by thinking about how those services can be connected? And when you're thinking about evaluating migrating into the cloud, think about these 9 points. Where does the funding come from? How scalable does your service need to be? What agility or flexibility you need? What maintenance or support capabilities do you have in-house? Do you need, can you use an in-house IT to work with you with an external cloud? Who is responsible? Accountability, always an interesting one. Who's the responsible party? PIs of projects, that's normally where the buck stops in academia. Where does that stop in industry? When we talk about competitiveness, it's about how do you scale for growth? Can you scale faster than the next guy? And of course, security. And I thought I'd end with an image of all of the different types of cloud service that are out there at the moment, in terms of all of the different types of end areas. So customer relationship managers, finance, accounting, business intelligence, collaboration. Who uses Dropbox? Up there in document management. Trello project management. Isn't it great? Why is that? Fantastic. But the point here is, actually, this is an exploding market. There are many services out there that can not only support from the point of view of different service types, but also essentially different capabilities.